Welcome back to section 3.5. We're going to be talking about writing exponential and logarithmic models. So you can see our growth model and our decay model. Only difference is for growth, our exponent's positive. For decay, our exponent is a negative. So looking at these, in a research experiment, population of fruit flies is increasing according to the law of exponential growth. So it's saying that it's exponential growth. So we know it's going to be in the form of y equals a e to the bx. Now, x is the number of days, and y is the number of flies. So what we have here is we can write two equations. So looking at this, 2 days, 100 flies. So that's 2, 100. 4 days, 300 flies. 4, 300. So we're going to substitute. 100 equals A times E to the 2B. 300 equals A E to the 4B. Now, one of the ways we can solve this, there's multiple ways to do it, is what I like to do is we're going to be undoing that multiplication so we can divide these two equations. Put the equation with the larger exponent, the 4b, we're going to put that on top. 300 equals a times e to the 4b. And we're going to divide that by 100 equals ae to the 2b. Now, when we divide these, 300 divided by 100 is 3. The a's cancel out, so we're left with e, and then subtract the exponents. 4b minus 2b is 2b. Now we have one variable to solve for. To undo the e, we're going to use the natural log on both sides. So the natural log of 3 equals the natural log of e to the 2b. Natural log of 3 equals the natural log of e. They cancel, 2b. Divide both sides by 2. And we're going to get that b equals the natural log of 3 divided by 2, which is 0.549, and we'll just go 0.55. Now we can find a by going back into one of the original equations. Let me use the first one. 100 equals a times e to the 2 times 0.55. So 100. So to get a by itself, divide both sides by e to the 2 times 0.55. Sorry, can't talk. So the a cancels. So a equals, and 100 divided by 2 e times e to the 2 times 0.055 is 33.35. So our model, y equals 33.35 times e to the 0.55x. There's our model. Now the second part says, how many flies will there be in 5 days? Well, that's our value for x. So when x equals 5, y equals 33.35 e to the 0.55 times 5. And you're going to get 521.7. Since they're flies, we'll either round up or round down. Either one is fine. So y equals about 521. I'm going to round down. So about 521 flies. And that's how we can write that exponential growth model. Let's go to the next page, please. For number 2, the number y of hits a new search engine website receives each month can be modeled by y equals 4,080 e to the kt. And t is the number of months the website has been operating. In the third month, 10,000 hits. So we can write that as an ordered pair. 3, 10,000. So what we want to do is we need to find the value of k first, and then we can make a prediction. So our equation, y equals 4,080 e to the kt. That was our given equation. So y, that's our 10,000, equals 4,080 e k times t, which is 3. Divide both sides by 4,080. We need to isolate the e. So we get about 2.45 equals e to the 3k. To get rid of e, we're going to use the natural log on both sides. Natural log of 2.45 equals the natural log of e to the 3k. The natural log of 2.45 equals 3k. Divide both sides by 3. K equals, and that's going to be about 0.3. There's our value for k. So our model, y equals 4,080 e to the 0.3 t. There's the model for this information. So now it says how many months or how many hits do we expect after 24 months? That's when t equals 24. So y equals 4,080 e to the 0.3 times 24. So y equals, and you're going to get about 464,877.519. So we'll just round it down. You can't have a partial hit. So there we go. That's the number of hits you'd expect after that many months. Number 3. The number of bacteria, N, is cultured by this model. N equals 250 e to the kt. T is the time in hours. So if N equals 280 when T equals 10. So what we can do is we can write this as an ordered pair. 10, 280. There's our ordered pair. So what we could do is we can substitute that in. Remember, N equals 250 e to the kt. We need to find out what k is first before we can do anything else. So 280 equals 250 times e to the k times 10. Divide both sides by 250 to isolate the e. And you're going to get about 1.12 equals e to the 10k. Undo the e with a natural log of 1.12 equals the natural log of e to the 10k. Natural log of e can cancel out, so you get the natural log of 1.12 equals 10k. Divide both sides by 10. K equals. So when you find that out, you're going to get about 0.011. So we have what we need for our model. N equals 250 e to the 0.011 t. Now it says, how long will it take for the population to double in size? Now the initial population, that's when t equals 0, and that's going to be 250. That's our value for a there. Now to double, when you double 250, you get 500. We need to find out how long. We need to find out what t equals that. So 500 equals 250 e to the 0.11 t. Divide both sides by 250. 2 equals e to the 0.11 t. 011, sorry about that. And now take the natural log of both sides. Natural log of 2 equals the natural log e raised to the 0.11t. The natural log of 2 equals 0.011t. Divide both sides by 0.011. And you're going to get t is about 63.01. So it's going to take about 62 hours. Sorry, 63 hours to double in size. Still just more solving these exponentials. Okay, next page, please. Actually, let's make the next page a second video. Thank you, and I'll see you in the next one.